Hi everyone. So today we will discuss the January 2022 F1 paper. Starting with question number 1. So they have given you the matrix M, a 2 by 2 matrix. Find the range of values of X for which the determinant of M, matrix M is positive. So what do we need to do? First you have to get the determinant. Tell me how do we find the determinant of a 2 by 2 matrix? You multiply the elements along the main diagonal. So we get here 3x into 2 minus x minus 7 times 4x plus 1. What do we get here? 3x into 2 is 6x minus 3x into x is 3x square minus 7 into 4x is minus 28x minus 7 into plus 1 is minus 7. Can you all tell me the simplification? Minus 3x square plus 6x minus 28x is minus 22x and then minus 7. So they are asking you after you get this equation, they are asking you to find the range of values of x for which the determinant of the matrix M is positive. So you need to find the range of values of M, a range of values of x for which the determinant M is positive, greater than 0. So get your determinant M minus 3x square minus 22x minus 7 greater than 0. Is that okay? So I think everyone is negative. Shall I take it to the other side and take it to the other side of the inequality sign? Minus 3x square comes here as plus 3x square plus 22x plus 7. This is okay? Okay, so does it factorize well? Can I know the factors? 3x plus 1 and x plus 7. So basically these are your two figures. So this is actually what? A quadratic inequality. So you have to solve the quadratic inequality and find the region where this now in according to my inequality I got 3x plus 1 x plus 7 is less than 0. Less than 0 means what? It's supposed to be negative. Okay, so you could draw a number line or you could draw the graph. Anything is okay. So I'll just draw the number line. What are the critical x values? 3x plus 1 means the critical x value is x equal minus 1 over 3. Other critical x value is x equal minus 7. So mark it properly. X is minus 7 is smaller. X equal minus 1 over 3 is comparatively larger, right? Okay, so then what are the regions? So test values on either side and you need to so take your calculator. Okay, type the expression or you can draw the graph. Any of the methods are fine. And then test each region, right? So we need the region where what? Where y is 3x plus 1 x plus 7 is less than 0. Can you see? It's supposed to be less than 0. So shall I type this in the cal? 3x plus 1 times x plus 7. Okay, so this is the expression. But so tell me the values in the first region. In this region, we can give any x value we want. Any x value less than minus 7, minus 8, minus 9, minus 10, anything. Yeah. So which one? Calc, give me a value. Minus 8. So do you get a positive figure or negative figure? It's a positive figure. You could type any x value less than minus 7. It could be anything. So for all those x values less than minus 7, you will get what answers? Positive answers. Okay, then what about any x value between minus 7 and minus 1 over 3? Tell me a figure. Calc, yeah, what's the x value you want to put? Minus 5, okay. So you can see it's negative. You can use any x figure in between minus 7 and minus 1 over 3. Okay, any x value. It could be decimal, it could be integer, just any x value and you get the answer. So minus 33, which is negative. Do you agree with me? And the other part, give any x value greater than minus 1 over 3. What do we get? Give me an x value greater than minus 1 over 3. 1, 2, anything. Just give any x figure. It doesn't matter what it is. Okay, x is 1. Anything bigger than it. So we get a positive figure here. Do you agree? So what do I need? I need the range where this inequality is supposed to be what? Less than 0. So the negative region. So this is the negative region. In between where and where? In between minus 7 and minus 1 over 3. So if you are used to drawing the graph and doing it, do it in that manner. There's no problem. Just that you need to give the region. So you can see x is greater than minus 7, less than minus 1 over 3. Do we use the equal mark at any of these two places? No, because we don't have the equal mark over here. We will not use the equal mark here. Okay, so this is your range. The range of values of x for which the determinant of M matrix M is positive. Your determinant will be positive for x values that are falling in between this range. Is this clear? Okay, moving on to question number 2. The complex numbers z1 and z2 are given by z1 equal 3 plus 5y and z2 equal minus 2 plus 6i. Show z1 and z2 on a single argon diagram. So z1 equal 3 plus 5y, z2 equal minus 2 plus 6i. Okay, shall we draw it on the argon diagram? So first in this side, this is the x-axis, this is the y-axis, x is the real axis, y is the imaginary axis. So what's the first coordinate? Real coordinate 3, imaginary coordinate 5. So you can mark 3, 5, right? Are you okay with that? Okay, so 3, 5, and the other one? Minus 2, 6i. So you can mark the two coordinates. Z1, this is Z2. Are you okay with that? Show Z1 and Z2 on a single argon diagram. So you can mark your points Z1 and Z2. Do you mark it? Okay, is this okay? Okay, so mark the points Z1, Z2 on the single argon diagram. Okay, then, yeah. Okay. And then they say part B without using your calculator. So very clearly you can see that they have written in bold, it's written in bold, without using your calculator and showing all stages of your working, determine the value of modulus Z1. Now remember, when they say to use without using your calculator, the thing is, how do they determine that you didn't use the calculator? They determine it from the amount of steps that you write. Okay, you can use the calculator. Okay, but the thing is that you need to convince your examiner to give you the mark. So to convince your examiner to give you the mark, you must write all the necessary steps, because that's what it tells them that you didn't use the calculator. Okay, so modulus Z1. Okay, so basically they have no way of checking whether you use the calculator or not. You use it. Okay, but you must write the necessary steps. So what is it? Modulus, how you take it? You square the real part and you square the imaginary part. It's not 5i. 5i means the imaginary. So just 5. Just take the 5 and square root. So this is the critical step. 3 square plus 5 square. Okay, so here of course you can now type this in the calc because they have no way of verifying. Okay, but this critical step must be written. So 3 square plus 5 square. How much is it? 9 plus 25, 9 plus 25, 34. So root 34. So without using the calc, this is what you should get. Are you going to write decimals here? Definitely not. Okay, because without using the calc means you cannot simplify. So you will leave it at this point. Is it clear? Roman number 1. Roman number 2. Express Z1 over Z2 in the form A plus BI, where A and B are fully simplified fractions. So again, this one, without using the calculator. So you must again show all the relevant working. Z1 is 3 plus 5y. Z2 is minus 2 plus 6i. Okay, so what are the necessary steps you need to show? Now, if you type this in the calculator, it will give you the final answer directly in one go. So how do you show the relevant step? What's the step you should show here? Now, you know, to keep this in this form A plus BI, you can't have any imaginary number in the denominator. How do you remove the I in the denominator? Rationalize, which means you multiply up and down with what? Minus 2 plus 6i. So you can multiply with minus 2 minus 6i. Are you okay with that? Just change the sign of the imaginary part in the denominator. Okay. So what do you get here? Show all the relevant steps. So shall we multiply? What do we get here? So make sure you show the multiplication out. 3 times minus 2 is minus 6. 3 into minus 6i is minus 18i. 5i into minus 2i is minus 10i. 5i into minus 6i is minus 30i square. Is that okay? Okay, the denominator minus 2 into minus 2 is plus 4. Minus 2 into minus 6i is plus 12i. Plus 6i into minus 2 is minus 12i. Plus 6i into minus 6i is minus 36i square. Actually, for the denominator, you could be a little bit more smart and think, okay, it's actually difference of 2 squares. So you could use a square minus b square, but anyway, and then you can see the middle part actually will cancel out, right? Can you see? The middle part cancels out. Okay, so anyway, we can simplify either, or you can do the shortcut. Okay, what happens here? 30i square. What do we know about I square? We know I square is minus 1. That means what do I get here? Minus 1 into minus 30 is plus 30. Plus 30 and minus 6 is? Plus 30 and minus 6 is? Plus 30 and minus 6 is? Plus 24. Minus 89 minus 10i is? Minus 28i. Is this correct? And then what did we get here? 4 I square, again minus 1. So minus 36 into minus 1 is plus 36. Plus 36 plus 4 is 40. So then they want you to separate in A plus BI. Separate it out. 24 over 40 minus 28i over 40. Can you all simplify? What's 24 over 40? 3 over 5. What's 28 over 40? 7 over 10i. So this is your A plus BI. Make sure you show all these steps, because that's what tells them that you didn't use the calc. Okay, especially these opening of the bracket must clearly be seen. The multiplication by minus 2 minus 6i must be seen. Okay. Okay, moving on to the next part. Hence, determine the value of argument of z1 over z2, giving your answer in radians to 2 decimal places. Okay. So already we found z1 over z2, right? What was z1 over z2? z1 over z2 was, remind me again, 3 over 5 minus 7 over 10i. So they wanted to get the argument of it. So how do you get the argument? First you draw this on an Argand diagram. So what's the Argand diagram? 3 over 5. The x coordinate, the y coordinate is minus 7 over 10. Okay, so basically it's somewhere over here, right? Okay, now shall we get the angle? So what's the argument? Argument is measured from the positive x-axis, and in this case you can see we are measuring it downwards, right? So that means your angle is over here. This is your argument. So when you're measuring it clockwise, you know your argument is what? Argument is positive or negative? Argument is negative. Can we first get the angle here? Let's use tan theta. So tan theta is opposite over adjacent. By the way, when you're using tan theta, do not use the negative signs. You are just getting a distance. So use only the positive values, the distance value. Okay, so what's the opposite here? Who is the opposite for this theta? The 7 over 10. Are we going to use minus 7 over 10? No, please use the distance. It's just the distance, 7 over 10 units. And opposite over adjacent. Adjacent is the 3 over 5. So make sure your calculator is in what mode? Radian mode. Make sure your calculator is in radian mode. On top, it should read R. Okay. So in radian mode, you type tan inverse. So what is it? 7 over 10 divided by 3 over 5. Okay. So 7 over 10 divided by 3 over 5. Like, shall I just simplify this a little bit before I type it in the calc? Are you aware of how to simplify it? 7 over 10, 3 over 5. Are you aware that the 5 comes up and 3 stays down? Are you aware of it? The 5 goes up, the 3 stays down. Just to show you how that works. It's 7 over 10 divided by 3 over 5, right? This is what it really means. So 7 over 10 division to multiplication, the reciprocal, and you take 5 over 3. That's what you get here. 7 over 10 into 5 over 3. You could write immediately. Can I know the tan inverse of this? Tan inverse 7 over 10 into 5 over 3. How much is it? 0.8621. They want it in radian to 2 dp. So what's the answer? 2 dp? 0.86. Is that the final answer? No, your angle, your argument. So you can write here arg z1 over z2. Wait, first of all, we'll get here. This is minus 0.86. Are you okay with it? Arg z1 over z2 is minus 0.86. Is this clear? Question number 3, the parabola C has equation y square equal 18x. The point S is the focus of C. Write down the coordinates of S. So how do we write the coordinates of the focus? The focus, we normally write y square equal 4ax. And the focus is going to be what? The focus coordinate will be a comma 0, right? So in this case, you have to make your y square equal 18x also into that format. So can you all make this as a multiple of 4? So this is 4 times, shall I write this as 18 over 4? And you see what I did here? I just introduced because I need to make the 4ax formula, or else you could say this 18 is equal to 4a. Okay, so if you I mean, you could literally say, or else instead of writing like this, you could say the 18 should be equal to 4a. Do you agree with me? Which means a is equal to 18 over 4. In other words, when it simplifies, 9 over 2. A equals 9 over 2. So therefore, what's the coordinates of S? The coordinates of S is going to be 9 over 2, comma 0. Is that clear? Then they say in the next part, the point P with y greater than 0. So make sure you look into this. Y is positive. Okay. The point P with y positive lies on C. The shortest distance from P to the directrix of C is 9 units. Okay. So do you have a visual idea of what's going on here? Okay. So kind of like have a rough idea. I mean, draw a small diagram to get to understand what's really going on here. So this is my parabola. Okay, this is the parabola. So this is my directrix. The directrix, the focus is 9 over 2, comma 0, right? Can you see? I'm marking the focus. Then if the focus is 9 over 2, directrix will be x equal minus 9 over 2. Or we could say x plus 9 over 2 equals 0. Do you agree with me? Okay, now they say here the point P with y greater than 0 lies on C, which means the point P is on the positive part of the parabola. So you have point P here. And what are they saying? The shortest distance from P to the directrix. What do you mean by the shortest distance? The perpendicular distance. The perpendicular distance from point P to the parabola, which means it should be this perpendicular distance, is how much? Is 9 units. This is 9 units. Okay, so they are saying determine the exact perimeter of the triangle OPS. Okay, do you see the triangle here, OPS? So OPS, they want you to get the perimeter of the triangle OPS. Okay, basically you have to get the OS distance, of course we know, right? OS is the focus distance. You have to get the OP distance and the PS distance. Okay, so in a parabola, there is one very specific rule about the distance between any point on the parabola and the directrix and the focus. Can you all remember what that rule is? What is it? Any, I mean, if you consider any point on the parabola, the perpendicular distance to the directrix and the distance to the focus is the same, which means what? Let's say this point here is PM. I'm just randomly naming it as M. So in a parabola, PM distance is equal to whom? PM is equal to PS. This is the rule. Okay, now my diagram is not that great, but in a parabola, PS is equal to PM, which means what? Both of them are 9. So PS, PM are both 9. That solves one problem. The other one, OS distance is 9 over 2. So that's also okay. So what's the only distance we need to find? We need to find the OP distance. How do I get the OP distance? To get the OP distance, do you realize I need to actually know the P coordinate? How can we get the P coordinate? Okay, the thing is, first of all, you need to get the x coordinate of P. Can you tell me what's the x coordinate of P? How do you get the x coordinate of P? Now you can see here the horizontal distance MP is 9 units now, right? And do you see the distance here? Oh yeah. So how do we how do I get the how do you say? How do I get the coordinates of P? Okay. So the thing here is you need to realize this O to the directrix distance is how much? This distance is 9 over 2, right? Distance wise, it's 9 over 2. Okay. So if this distance is 9 over 2, do you realize it's the same distance over here? This is 9 over 2. So then from this entire distance 9, the MP distance, the horizontal distance 9, you need to what? Subtract this 9 over 2. So that gives you that gives you this remaining horizontal distance. Can you see the one that I marked? So this horizontal distance gives you the x coordinate of P, right? Because it's measured from the origin. It's measured from the y-axis. So from the y-axis, the horizontal distance you measure will immediately give you the x coordinate. So from this entire 9, the full distance, you subtract the 9 over 2. That gives you the remaining. How much is 9 minus 9 over 2? It's 9/2, which means this distance from the y-axis to point P, the horizontal distance is 9/2, which tells us what? The x-coordinate of P is 9/2. Can you all also get me the y-coordinate? How do I get the y-coordinate of P? How do I get the y-coordinate of P? So we use the equation. We have the equation of the parabola, right? What is it? Y square equal 18x. So you have your x-coordinate. Substitute the x-coordinate and get the y value. Okay, so then what happens here? Y square equal 18. The x-coordinate is 9/2, right? How much is the answer? 18 into 9/2 is y square equal 81. So when you take the y value, they have clearly told you y is greater than 0, which means y is root 81. We get plus or minus 9. So we should specifically take only the plus 9. Okay, so as some of you now suggested me, now you can see here, now you all were suggesting me the use of Pythagoras theorem here. Why? Because you were saying to me the s coordinate is 9/2 and p is also 9/2. What does that tell you about s and p? It tells you that p is directly above s. Because to get both x coordinates to be 9/2, it means p this is directly above s, isn't it? So then if you could like modify your diagram slightly, even I mean like even this method is okay. Okay, so there are many methods of doing the same sum. So you were suggesting me to redraw the diagram and to mark s over here, right? Over here. Okay, so this is the s. Why do you say this? Because p and s are both having the x coordinate 9/2. So I think if you take from that point of view, you can directly see without you don't have to find y in this manner in that case. Why? Now we know the ps distance is 9 units, and because p is directly lying directly above s, the distance 9 is going to be directly your y coordinate. So you could take the y coordinate just by observation. So this is another method of getting the y coordinate. Either you could take the y coordinate by substituting the x value into your main equation and getting y. You could get y in that manner. Or you could look at your diagram. So you have to draw your diagram and you see the p coordinate. Now you got the x coordinate of p, which is 9/2. So the x coordinate of your focus is also 9/2, which means p is lying directly above s. So that means it's directly above s means you have the perpendicular. I mean it's perpendicular. Thereby, you realize the PS distance 9 is directly the y distance. So thereby, you could take the distance as 9 in one go. Okay, so anyway, both methods are okay. Okay, so now I need to get the OP distance, right? I need to get the OP distance. Shall we get OP? So to get the OP distance, if you you can see here, either you could use Pythagoras theorem for the right angle triangle, or what else could you do? You could use the distance between two coordinates, x1 minus x2 square plus y1 minus y2 square holding square root, because O is 0, 0, right? The point O is 0, 0. So you could go with the x1 minus x2 square plus y1 minus y2 square root, or you could go directly with Pythagoras theorem and get OP. Any of the two methods is perfectly fine. Are you with me? Okay, so shall I go with the Pythagoras theorem? So if I use Pythagoras theorem, the x distance here is 9/2 square. The y distance is 9 square holding square root. So you could do this even by using x1 minus x2, y1 minus y2. Okay. How much is OP? Can I know the simplified answer in third form? 9 root 5/2. So you can type this in your calculator and get the answer. Okay. Type it in the calculator and it will give you directly the answer 9 root 5/2. Okay. How do we get the perimeter now? The question is to find the perimeter. So I will write it over here. Perimeter is what? You have to add the distance, right? You have to get OP plus OS plus PS. So what do we get? OP is equal to 9 root 5/2. OS is 9/2. PS is 9. So add all the three units and they do tell you here very clearly, give you an answer what in determine the exact perimeter. Can you see? Exact perimeter, which means you do not give decimals, you give your answer in third form. Can I know what happens when you add 9 over 2 plus 9? Give it separately, right? 9 over 2 plus 9 is 27 over 2, right? 27 over 2. So it's a common denominator. So you get here 9 root 5 plus 27 over 2. I think which doesn't simplify any further. So that's it. This is your exact perimeter. This is your exact perimeter for triangle OPS. Is this clear? Question number 4. The equation x to the power 4 plus ax cube plus bx square plus cx plus 225 equals 0, where a, b and c are real constants, has a complex root 4 plus 3i. A repeated positive real root. Write down the other complex root of this equation. You all know complex root always comes in what? It comes as a complex conjugate pair, right? So if you have 4 plus 3i, definitely the other root should be 4 minus 3i. So this is the answer for part A, 1 mark. Part B, hence determine a quadratic factor of x to the power 4 ax cube bx square plus cx plus 225. So what is the quadratic factor? You get the quadratic factor by the two roots, 4 minus 3i and 4 plus 3i. So to get the quadratic factor, you could use the, the way we get the quadratic factor, x square minus sum of root times x plus product. So this is one way of getting your answer, equals 0. So get the sum of your roots. So our two roots are 4 plus 3i and 4 minus 3i. What's the sum of the two roots? 4 plus 4, 8 plus 3i minus 3i cancels. What's the product of the two roots? 4 plus 3i multiplied with 4 minus 3i. Shall I directly use difference of two squares? A plus b into a minus b is a square minus b square. So a square minus 3i square. So a square 16 minus 9i square. 9i square is plus 1. No, I square is minus 1. Minus 1 into minus 9 is plus 9. 16 plus 9 means 25. So what's the quadratic factor? X square minus 8x plus 25. Okay, so this is the quadratic factor. Okay, this is the quadratic factor. No, this is the quadratic factor, not the quadratic equation. Get the quadratic factor. Okay, so there is another way of getting the quadratic factor, just to, so that because some of you might use different methods. The other way is, now your two roots are x equals 4 plus 3i and x equals 4 minus 3i, right? The other way of getting is you use x minus 4 plus 3i into what? X minus 4 minus 3i. So this is another way of getting the two quadratic factors. Again, you open this out and get the same answer. But I think this is a lot more easier to work with. Okay, so because you might be using this method as well. So any of the methods are fine. Okay. Okay, then we'll go to the next part. Part C, they ask you to deduce the real root of the equation. So real root means what? The root that doesn't involve any imaginary part. Okay, how do we find the remaining root? Now, the remaining root, they tell you very clearly it's a what root? It's a repeated possibly, not just a real root, but a repeated root. What do you mean by a repeated root? It means the same bracket comes twice. You get the same bracket twice. That's why it's a repeated root. Okay, now how do we find the real root of this equation? Okay, so in how do we get the real root? Now you do know here that we got one quadratic factor. So this quadratic factor multiplied with another quadratic factor is what gives you this other equation, right? X to the power 4x cube bx square cx plus 225. So now in part C, you need to realize we got x square minus 8x plus 25. So this should be multiplied with another quadratic factor. Do you agree with me? And they do say this other quadratic factor is a repeated positive real root, which means what? You have something of the form either, so we could say x plus a into another x plus a, because it's a repeated root. X plus a into another x plus a. So this is equal to what? X to the power 4 plus ax cube plus bx square plus cx plus 225. Basically, when you open this bracket, we need to get it. Get this. Are you with me? Now, let me write this here, x square minus 8x plus 25. It's just to deduce here. You can see it's just 2 marks. Okay. So you should not have to go through a lot of trouble here. X square plus 2x plus a square. Okay, I just opened this. Okay, x square plus 2x plus a square is what you get when you open the repeated root. Now, how do we determine the value of a? It's just 2 marks. You're not supposed to do a lot of work here. How can I determine the value of a here, the repeated root? Because you can see your root is the value that we get for a. How do we get the value of a? Now you need to realize here. Now you get x to the power 4 when you multiply the two x values here, right? X square gives you the two beginning terms, and you multiply, you get x to the power 4 here, right? Those are the only two terms here who contribute to give you x to the power 4. And do you see the very last term here? The very last term is 225. 225 is a constant. Which terms multiply together to give you a constant? The constant term is produced solely by what? The constant 225 is produced solely by the multiplication of 25 and the a square. Is there anyone else here who will involve to give you this constant 225? No, because every other term involves an x. Every other term involves x. So when you expand the bracket, every other multiplication will give you the x coefficient. The only person where the multiplication that doesn't give you the x coefficient is the multiplication between 25 and a square. So 25 multiplied by a square should produce the 225. Do you agree with me? So 25 into a square should give you the 225. How much is a square? 225 divided by 25. How much is it? 9. So I get how much for a? Root of 9, right? Root of 9. So square root of 9, I could get both plus or minus 3, right? But they do give us some, they say that the root is positive, right? So the root is positive. Then we need to decide whether our a value is positive or negative. So now we get here a is plus or minus 3, right? Now you know the root means what? The root is the value of x. Are you with me? So now the root is supposed to be positive. Your root is x equals, right? So x equals, the root has to be positive, which means x equals how much? The root is going to be x equals 3 because the root has to be positive. So if x equals 3, what's the factor? Your factor should be, the factor should be x minus 3. And this is what? A repeated root, right? The positive root is a repeated positive real, a repeated positive real root. So positive real root is x equal 3. Remember, it needs to be a positive root. So if it's positive x equal 3, the factor should be, when you take 3 to the other side, your factor is x minus 3. Are you with me? So what do they want us to find? They want us to find the reduce the real root. So what's the real root? The real root is x equals 3. Okay, so the factor is x minus 3. The repeated real root is x equals 3. They just want to ask the root. So your root is x equals 3. Is that clear? Okay, then the next part. Hence, determine the value of each of the constants a, b, and c. Basically, what should you do? What should you do? You need to expand the bracket. So let's expand the bracket in part D. So what do we have here? X square minus 8x plus 25. What's the factor? You realize if the root is x equal 3, the factor is x minus 3, right? X minus 3 repeated. So x minus 3 into another x minus 3. Do you agree with me? X square minus 8x plus 225. X minus 3 into x minus 3 is x square. What do we get here? Minus 3x. Are you with me? Minus 3x is minus 6x, and then minus 3 into minus 3 is plus 9. Shall we expand the bracket and get the values? Can you expand? Starting with x square. X square into x square is x to the power 4. X square into minus 6x is minus 6x cube, right? And then x square into plus 9 is plus 9x square. Are you with me? The next one, minus 8x into x square is minus 8x cube. Minus 8x into 6x minus 6x is plus 48x square, and minus 8x into plus 9 is minus 72x. Are we done yet? Now there's another one term to simplify. 225 into x square is plus 225x square. 225 into minus 6x is minus, multiply and tell me the answer. How much? 225 into 6. How much? Sorry, not 225. It should be 25. Yeah, sorry, it should be 25. Okay, so sorry, that means I need to fix the first one, right? Yeah, this needs to be fixed. Only the last part, right? The others are correct. Yeah, so only 25 into x square is 25x square. 25 into minus 6 is minus 150x. 25 into 9 is 225. Can you all add the like terms? X to the power 4, and then let's add minus 6x cube. You have to add with minus 8x cube, right? How much is it? Minus 14x cube, and then add the x square plus 9x square plus 48x square plus 25x square. How much is it? Plus 82x square. Is that correct? And then the next part, minus 72x minus 150x, which is minus 222x. And then the last part is plus 225. So I think you can see we can now determine the values of our A, B, and C. So A is the coefficient of x cube. Can you see ax cube? So who is A? Minus 14. Who is B? B is the coefficient of x square. So x square coefficient is 82. C is the coefficient of x. Cx. Cx is, C is how much? Minus 222. This is clear? So these are the values of your A, B, and C. I hope all of you understood what I did here. Question number 5. Okay, so the you can see there's a 2 by 2 matrix here. The matrix P represents the transformation U. Give a full description of U as a single geometrical transformation. Okay, how do you give the single geometrical transformation here? So what do we do here to describe the single geometrical transformation? Always when they ask you to describe the transformation, how do you, what do you check it against? With what do you check it? Okay, so you always check it against the identity matrix, right? 1 0 0 1. 1 0 0 1 is the identity matrix, which we consider as the original matrix. So then you compare the movement of the matrix P along with this matrix to see what kind of a transformation has taken place here. So 1 0 0 1 is, we say we take the coordinates downwards, right? 1 0 is the first coordinate, 0 1 is the second coordinate, because we take coordinate downwards. So the first coordinate 1 0 is over here. Do you agree with me? 1 0 is over here. So I take it, this is the first one, and the second one 0 1 is over here. So normally in the book they mark this as I and J, right? Okay, so I just denoted it with some denoted in this manner. Now what we do here is we need to check it against what? So what is P? Half root 3 over 2 minus root 3 over 2 and half. So can we quickly draw and check what is the transformation that has taken place over here? Half and root 3 over 2 means you can see half is somewhere like over here, root 3 over 2. So basically the first coordinate is over here, right? The first arrow. So you can see the way the arrow has switched. I think we can clearly see this. This has moved a certain amount upwards, right? It has. I think we can see there's a rotation involved here. The second coordinate is minus root 3 over 2 plus half. Plus half is 0.5. Root 3 over 2 is how much? Root 3 divided by 2 is it's 0.866, which means half is comparatively lower than root 3 over 2, right? Okay, so the other point is over here. Because you need to realize the first coordinate is the first coordinate is given by half root 3 over 2. The second coordinate is given by minus root 3 over 2 half. So can you see the way the arrows, how they have moved? So you can see the first arrow, which was over here, has come over here now. The second arrow, which was over here, has come over here. So clearly you can see we definitely have a rotation here. So all you have to do is determine the angle of the rotation. I think you can clearly see it's a what rotation. We can say it's a anti-clockwise rotation. Anti-clockwise rotation by how much? Just determine the theta angle. Can you see the theta angle here? So get the theta angle by using one of the two coordinates. So the angle theta should be the same from either end. Can you see? Either theta, you take it from from this one or from the other one. So I will take it from the first one, the first arrow. Okay, what do we get here? Tan theta equals to opposite over adjacent. Opposite is yeah, 3 over root 3 over 2 divide by half. Are you with me? Opposite is root 3 over 2 divide by half. Okay, so tan inverse Numerical, you could give your answer here in degree or in radian. It's fine. Anything is okay. So if you could give your answer the theta value in degree or in radian. How much is it in degrees? So basically this is root 3 over 2 into 2 over 1, right? So 2 and 2 cancels. It's basically root 3. So by now you should know tan inverse of root 3 is 60 degrees. So basically this is 60 degrees. So what has happened here? It's a rotation about 60 degree anti-clockwise. Also have a habit of checking whether there is also whether there is an enlargement. Now what do I mean by an enlargement? Now you can see in the original diagram, the arrow is only 1 unit in length, right? It's only 1 unit. So when you are checking for the transformation, sometimes there is a chance that there might be that there might be an enlargement. So how do you check whether this arrow, whether it's been enlarged or not? Now you know the original magnitude of the arrow is 1, right? So what you do here is apply. Now you have the two coordinates of the arrow here. Take the two coordinates and apply what? Pythagoras theorem. Because when you apply Pythagoras theorem, you can get the magnitude of the length of the arrow along the hypotenuse. Can you check whether the value becomes 1? So what do we have here? I get here half. I get here half square. Plus the other one is plus the y coordinate is root 3 over 2, right? Root 3 over 2 whole thing square. Are you with me? And then you have to get the square of these two, get the answer and root it. So I get here half square plus root 3 over 2 square is 1. So root of that, right? When you apply Pythagoras theorem, it's 1. So is there any enlargement here? No, because you can see the original length of the arrow is 1 and even the rotated arrow is also still 1 unit. So in an event, if you got the length here, when you apply Pythagoras, if you got it as 2, that means there's a enlargement scale factor 2 as well. Okay, so that's really important. So anyway, in this case, I only have a rotation. So you can say here, this is a rotation about O or rotation about 0, 0, 60 degree rotation, sorry. Rotation about O, 60 degree anti-clockwise. Is this clear? Okay, then let's move to the next part. In the next part, they say the transformation V represented by the 2 by 2 matrix Q is a reflection in the line y equal minus x. Write down the matrix Q. Again, the story is quite similar. It's just 1 mark. How do you get it? You draw your original matrix 1, 0, 0, 1 and what? And you perform a reflection in the line y equal minus x. Shall we reflect? So 1, 0 is over here. 0, 1 is over here, right? Okay, so I'm supposed to reflect this in the line y equal minus x. Where is y equal minus x? Y equal x is the one that goes in the middle here, right? This is y equal x. I want y equal minus x. Who is y equal minus x? Y equal minus x goes from the other side, right? So this is y equal minus x. So what happens when you reflect on y equal minus x? You need to realize that this point comes over here, right? And this point comes over here. Shall we draw it? So what happens? The double arrow shifts over here. What's the new coordinate? It was on the y-axis. Now it falls to the negative x-axis, which means it's going to be what? The length. Does the length change? The length is 1 unit. Thereby the length doesn't change. So it will become, its coordinate is minus 1, y coordinate is 0. And the single arrow comes down over here, right? The length doesn't change. Here length is still 1 unit. So what is the coordinate at this point? X coordinate is 0, Y coordinate is -1. So how do you write the transformation V? Transformation V represented by the matrix R. So write matrix R. R equals, first you must write the arrow, the first arrow, the one with the first arrow. What is it? The coordinate is 0, -1. The first coordinate is 0, -1. The second arrow, it's -1, 0. Okay, you cannot exchange this order. This order cannot be changed. You must first write the arrow of the single arrowhead first, or sometimes they denote it in the book. This is denoted as I and this is denoted as J. So I must be written first, J must be written second. I coordinate should be written first. In my case, I denoted I as a single arrowhead and J as a double arrowhead. I must be written first, J must be written second, and you cannot switch that order. If you switch it, your matrix is completely wrong. Okay, make sure you write it in that correct order. Okay, is this clear? So this is matrix R. Then let's move to the next part. They say the transformation W is represented by the matrix 3R. Okay, so 3R. The transformation W maps a triangle T to a triangle T dash. The transformation W dash maps a triangle T dash back to the original triangle T. Determine the matrix that represents W dash. Okay, how do we find W dash? First of all, I think we can get the matrix, the transformation W is represented by the matrix 3R. Okay, can we get the matrix 3R? The transformation W is represented by the matrix 3R. Can I get 3R? Who is 3R? Get the matrix 3R first. Yeah, sorry. First, we need to do part C first, right? And part C is matrix R. I'm sorry. In part B, we are supposed to the transformation V represented by the 2 by 2 matrix Q is a reflection in the line Y equal -X, right? So this is not matrix R. This is matrix Q, right? Okay, so please make sure you read the question. So they say here it's matrix Q. Okay, so make sure this is matrix Q. Matrix C is in matrix R is in part C. Shall we do part C now? In part C, they say the transformation U followed by the transformation V is represented by the matrix R. Okay, are you following the transformations here? Who is transformation U? Transformation U is represented by matrix P. Are you with me? So U is given by matrix P and transformation V is represented by matrix R, right? So transformation V is represented by matrix R. Are you with me? So U is given by matrix P. Transformation V is represented by matrix Q. Is that correct? Transformation V is represented by matrix Q. Just make sure you follow along the lines that I'm talking here. Okay, now they say transformation U is what? Transformation U followed by the transformation V is represented by matrix R. Do you remember this followed by rule? So when you have followed by rule, do you remember how we write the matrices? Do we write the matrices in this given order? Transformation U followed by transformation V means do we write V after U, to the right of U or the left of U? You do need to remember that the matrices are written in the reverse order, right? So here when they say transformation U followed by transformation V, U is written in the right side, V should be written to the left side. We should actually write the real matrices here. So transformation U is what? Matrix what? Transformation U is matrix P followed by transformation V is matrix Q. So basically it's P followed by Q. So P followed by Q, am I supposed to write as PQ or QP? P followed by Q. The Q must be written behind P. Must be written to the left of P. Okay, so this is how we write the followed. Okay, so you learn about this rule in the matrices chapter. Okay, so P followed by Q. It's not PQ, it's QP. Okay, so this is very clearly explained in the textbook. It's very clearly explained. So make sure you know about these rules. Okay, you are supposed to multiply these two matrices and get the matrix R. Can we multiply? Who is Q? Q is 0, -1, -1, 0. And who is matrix P? Let's multiply. It's half √3/2 minus root 3 over 2 and half. Okay, you're supposed to multiply. Can you all multiply? So you could use the calculator to multiply here, or I think it's better you go manually because you need to know the exact figures here. Shall we work on it manually? So this is a 2 by 2 matrix. It's a 2 by 2 matrix. So what's the resulting matrix? The resulting matrix, so you can see you can multiply the matrices here. The resulting matrix is found by the, is a 2 by 2 matrix here, right? The resulting matrix is a 2 by 2 matrix. And I have told you how to get the resulting matrix, right? Okay, so there are 2 rows and 2 columns. Basically, there are 4 elements. How do you get the first element? The first element is found by multiplying the which row? There are 2 rows and 2 columns, right? So the first matrix will provide you the rows you need for the multiplication. The second matrix will provide you the columns you need for the matrix multiplication. Are you aware? Okay, so we are going to do the matrix multiplication. So the first element is found by what? Multiplying row 1 with column 1. So when you multiply row 1 is 0 minus 1 with column 1. Column 1 is half root 3 over 2. Remember, rows are provided by the first matrix, columns are provided by the second matrix. So multiplying row 1 with column 1 gives you the first element. This is the first element. The second element is found by what? Multiplying row 1 with column 2. Who is row 1? Row 1 is 0 minus 1. Column 2 is minus root 3 over 2 and half. Are you with me? Then the third element you get by multiplying what? Which row and which column? Row 2 and column 1. Who is row 2? Row 2 is minus 1, 0 along with column 1. Column 1 is half root 3 over 2. Do you follow me? The last element is found by multiplying row 2 with column 2. Row 2 is minus 1, 0. Column 2 is minus root 3 over 2 and half. So shall we multiply? You can write this answer immediately if you are good in the multiplication. You don't need this extra step that I'm writing here at all. You don't need it. You could write the answer immediately. Shall we immediately multiply? What do we get here? 0 into half is 0. Minus 1 into root 3 over 2 is minus root 3 over 2, which means your first element is minus root 3 over 2. Are you with me? The second element, 0 into minus root 3 over 2 is 0. Minus 1 into half is minus half. So second element is minus half. Are you with me? The next element, minus 1 into half is minus half. 0 into root 3 over 2 is 0, which means when you add these two, you get minus half, because you're supposed to add these two answers that you get after multiplying. The last one, minus 1 into minus root 3 over 2 is plus root 3 over 2. You have to add it with 0 into half is 0. So nothing to add there. So this is your matrix. Who is this? R. This is the matrix R. Matrix R found by multiply matrices in the order QP. Is this clear? Okay. Shall we move to part D now? I think I was reading part D earlier. So now I need to move to part D. Shall we go to part D now? Okay, in part D, they say the transformation W is represented by the matrix 3R. The transformation W maps a triangle T to a triangle T dash. Okay. The transformation W dash maps the triangle T dash back to the original triangle T. Determine the matrix that represents W dash. Okay. What do you think we need to do here? First of all, part D. The transformation W is represented by what? First of all, it's represented by the matrix 3R. Can you all get me 3R matrix first of all? 3R is what? 3 times. Who is the R matrix? We just found R, right? Who is it? Please read out the coordinates. Minus root 3 over 2, minus half, plus root 3 over 2. Can you all get me the 3R value? 3 into minus root 3 over 2 is 3 root 3 over 2. 3 into minus half is minus 3 over 2. 3 into minus half minus 3 over 2. 3 into root 3 over 2 is 3 root 3 over 2. This is the 3R matrix. Are you with me? Now they say this 3R matrix is what? Is given by the transformation W. So what does transformation W do? It maps the triangle T to triangle T dash. T is the image object, T dash is the image. And then the transformation W dash, what does that do? It maps the T dash back into the original. So tell me, what kind of a matrix will take the image back to the object? Which matrix will take the image back to the object? Which matrix? Now you have a transformation that takes you the, now you say you have a transformation, let's say you have this transformation x takes you from the object to the image. Okay, then if you want to now from object to image, okay, so object to image, you say you apply the transformation x, which takes you from the object to the image. How do you come back from the image to the object? By applying x inverse. The inverse matrix will take you back from the image to the object. So thereby, what do I need to do here? W dash is going to represent the inverse. The inverse of what we have. Now, what is the matrix that we use for the transformation? For the transformation, we use the matrix 3R. So if you want to find the transformation given by W dash, it should be represented by what? It's the inverse of the 3R matrix. Do you understand what I'm talking here? Okay, so W dash is the inverse of the 3R matrix. Are you all with me? It's the 3R inverse. So is it so difficult to find the inverse matrix of 3R? So we already have the 3R matrix. You know how to find the inverse matrix, right? How do you find the inverse matrix? You have to get the determinant, right? First thing is to get the determinant of the matrix. Get the determinant and then you switch the elements along the main diagonal and switch the signs on the other diagonal. Shall we do it? Okay, let's get the determinant. Determinant of 3R matrix. What's the determinant? Multiply minus 3 root 3 over 2 multiplied by 3 root 3 over 2 minus, are you with me? I multiplied these two, minus, you multiply minus 3 over 2 with minus 3 over 2. Are you following what I'm doing here? I multiplied these two elements. In the middle, there's a minus, and I multiply the other two. Can I know how much is minus 3 root 3 over 2 into 3 root 3 over 2? Minus 27 over 4. Can I know how much this is? Minus 3 over 2 into 3 over 2 is plus 9 over 4. So this is going to be a minus sign outside anyways, right? Minus 27 over 4 minus 9 over 4 is minus 9. So determinant of 3R is minus 9. So now can't we get the 3R inverse matrix? So 1 over determinant 3R, isn't it? You remember how we get the inverse? 1 over determinant of 3R, which is minus 9. And then you take your matrix. Along the main diagonal, elements are switched. So you get here what? 3 root 3 over 2 comes up here. This comes here. And minus 3 root 3 over 2 comes to the other side, right? And on the other diagonal, the signs are switched. Both are minus 3 over 2. Both of them will become plus 3 over 2. Are you with me? Shall we multiply inside with minus 1 over 9? Can you multiply minus 1 over 9? So you can type it here. I'll do the first one. Minus 1 over 9 multiplied by 3 root 3 over 2. What do you get? We get minus root 3 over 6. Can you see? Can you multiply minus 1 over 9 into 3 over 2 is minus 1 over 9 into 3 over 2. How much? Minus 1 over 9 into 3 over 2. Minus 1 over 6. Next one, minus 1 over 9 into 3 over 2. Again, minus 1 over 6. Minus 1 over 9 into minus 3 root 3 over 2 should be positive root 3 over 6. So this is it. This is the W dash matrix. The transformation represented by W dash is the inverse of the 3R matrix. Okay, so I think they want the simplest form. Determine the matrix. Yeah, so you could keep your answer in this, but I think better to keep your answer in the simplest form. Okay, so do you? I hope you understood what they meant by W dash here. Were you clearly able to understand that W dash is the inverse of the 3R matrix? Because 3R matrix takes you from T to T dash. So they want you to find a matrix that takes you back from T dash to T. So to take from the image back to the object is definitely the inverse matrix. Okay, so we take the 3R matrix and get the inverse of it. So you know how to find the inverse of a 2 by 2 matrix. So I just applied those rules here. Okay, is this clear? Okay, I hope all of you understood what I did over here. Question number 6, the quadratic equation ax square plus 5x minus 12 equals 0, where a is a constant, has roots alpha and beta. Write down an expression in terms of capital A for alpha plus beta. So you are, I hope you are all familiar with this. What's alpha plus beta normally in a quadratic equation? Alpha plus beta is given as minus b over a. So who is b here? A is capital A, right? A capital A x square. So the x square coefficient is a, that's capital A. The b is the coefficient of x, which is 5. C is minus 12. Shall we use the values here? Minus b is 5 over a is capital A. Do you agree with me? And then alpha beta. Alpha beta is c over a. Who is c here? Minus 12 over a is capital A. Do you agree with me? Then they say here in the next part, okay, the first part is done. In terms of capital A, we wrote both of them. The next one, the equation 4x square minus 5x plus capital B equals 0, where B is a constant, has roots alpha minus 3 over beta and beta minus 3 over alpha. Part B determine the value of A. Okay, now how do we come to this equation? Once again, what's the rule that we use? What is the rule that we use in questions like this? Now they have told you this quadratic equation is having these two particular roots. So if you have a quadratic equation with these two particular roots, what do we get here? Yeah, we can get here. Yeah, what do we do here? Okay, so then the question you have here is that these two quadratic equations are the same. Okay, so it's not. Okay, you can't compare these two and write the value. Obviously, no, right? These two are two different equations. They said this equation has these two roots. Okay, so you can see here now the first equation had roots alpha and beta, while the other equation you can see it has a completely different set of roots. Can you see? So you cannot say that these two are the same. They are not the same, definitely. Okay. So what we do here is, shall we go with the sum of roots and product of roots here? So you need to realize here that with this equation, what's the sum of roots? The sum of roots is going to be what? Can you tell me the minus b over a value here? According to this equation, who is minus b over a? Minus b value is minus 5, right? A value is 4. So your sum of roots is 5 over 4. Do you agree with me? I'm not going to use alpha plus beta over here because our roots are not alpha and beta over here. Our roots are alpha minus 3 over beta and beta minus 3 over alpha. So sum of roots in the second equation is not just alpha plus beta. Who is the sum of roots here? The sum of roots will be alpha minus 3 over beta. You have to add with beta minus 3 over alpha. This is the sum of roots. And this sum of roots should be equal to 5 over 4. Do you agree with me? Because the sum of roots here is, you take these two as the two roots now. So sum of roots is equal to minus b over a, even in this equation. So minus b over a is minus, b is minus 5, c is 4. A is 4 minus b over a. So minus 5 over 4 gives you plus 5 over 4. Sum of roots are, they just add the two roots here. Your first root is alpha minus 3 over beta. Add it with the second root, beta minus 3 over alpha. What do we get? Can you all simplify? Alpha minus 3 over beta plus beta. I'll bring the like terms together. I get here minus 3 over beta minus 3 over alpha. Shall we simplify here? I think alpha plus beta we already know, right? Who is alpha plus beta? Can you see alpha plus beta is minus 5 over a. So we will use the help from part A. Can you all simplify minus 3 over beta minus 3 over alpha? Shall I take minus 3 out from here? When I take minus 3 out, what do I get here? 1 over beta plus 1 over alpha. Do you agree with my working? I took minus 3 out. So I get 1 over beta plus 1 over beta plus 1 over alpha. Shall we simplify? Shall we take the common denominator here? Who is the common denominator? Alpha beta. And then on top you get beta is there. So you are missing an alpha component here. Here you are missing a beta component. So which means your numerator becomes alpha plus beta. Is that okay? Equals 5 over 4. So I get here minus 5 over a minus 3 times. Shall we simplify? Alpha plus beta is? Alpha plus beta is minus 5 over a. Divide by alpha beta is? Alpha beta is minus 12 over A. Are you with me? The simplification here is going to be a little bit of a challenge. So I think by now all of you should know that the A to A here, if you can't see, it cancels out. Okay, so I will write it in the basic way, but if you can go quickly, you should go minus 3 into minus 5 over A. You could write the main division here as division in this manner. Okay, if you have issues in writing the answer directly. Okay, do you see what I did here? So I'm just showing you the basic way. If you can write it directly, you can write directly. Now I wrote here, I'm showing you the basic steps here. Minus 5 over A divide by minus 12 over A. Okay, so minus 5 over A is there separately. Minus 3 into minus 5 over A. Division turns to multiplication and this becomes A over minus 12. Are you with me? Are you with me? So first we must do the multiplication first. What happens here? A will cancel out. Can I know the value that I get over here? Minus 5 over A. Here multiply minus 3 with minus 5 with 1 over minus 12. How much is it? Minus 3 into minus 5 into 1 over minus 12. How much is it? Minus 5 over 4 equals 5 over 4. Okay, so now your task is to make A the subject. Can you all make A the subject? Minus 5 over A. I'll take minus 5 over 4 here. 5 over 4. Minus 5 over 4 comes as plus 5 over 4. How much is it? Minus 5 over A equals 10 over 4. Can you all make A the subject? Either you can flip both of them or just cross multiply. The simplification is entirely up to you. Minus 5 into 4 equals 10 into A, which means A is minus 5 into 4 over 10. How much is it? Minus 40 divided by minus 20 divided by 10 is minus 2. So A is minus 2. This is the answer for part B, right? Yeah, this is the answer for part B. This is clear with you all? Capital A is minus 2. Okay, and then I'll go to part C. Next one, determine the value of B. Okay, how do we get the value of B? Obviously, now in part B, I use the sum of roots. For part C, I will use the product of roots. So how does the product of roots work here? Product of roots is C over A, right? What's C according to this equation? According to this equation, C is the capital B, right? The C is the coefficient without any X. So C is capital B, A is 4. Are you all with me? So what's the product of roots? Multiply it out, right? So product of roots is alpha minus 3 over beta is the first root. Second root is beta minus 3 over alpha is equal to B over 4. Shall we multiply? What do we get here? Alpha into beta is alpha beta plus alpha into minus 3 over alpha is, how much is it? Minus 3 over alpha times alpha. Next one is minus 3 over beta times beta. Are you following me? Minus 3 over beta times beta. The last one, minus 3 over beta into minus 3 over alpha is plus 3 over beta into 3 over alpha is 3 into 3 is 9. Alpha into beta is alpha beta equals capital B over 4. Are you following me? Here the alpha and alpha cuts, the beta and beta cuts. So are we going to, simplify or take any common denominator here? It's absolutely not necessary because alpha beta value is already known. What's alpha beta? Alpha beta is minus 12 over A. Are you with me? Alpha beta is minus 12 over A. Substitute here, I get minus 3 plus 9 divided by alpha beta is again minus 12 over A. Are you all with me? Equals B over 4. So I think we just found the A value, right? What was the A value we got? A value was minus 2. So we just need to replace the A value as minus 2 and make B the subject. So minus 12 divided by A is minus 2. In here, shall I add the minus 3 and minus 3? Minus 3 plus minus 3 is minus 6. Are you with me? Plus 9 over minus 12 divided by A is minus 2. Equal B over 4. Can you all tell me what I get here? Minus 12 divided by minus 2 is plus 6. And here you get minus 6. What's the value here? Minus 12 divided by minus 2 is plus 6, right? Are you with me? So here the plus 6 minus 6 will cancel out. And I get here 9 over 6 equals b over 4. What do we get for b here? B equals, the 4 goes as a multiplication, 9 over 6 into 4. Can I know the simpler, the answer for b? 9 over 6 into 4 is 6. B is equal to 6. Yeah. So that's it. So determine the value of b. The value of b is equal to 6. Are you clear with this? Okay, question number 7. They say in this question, you must show all stages of your working. Solutions relying entirely on calculator technology are not acceptable. So you must show all the working and show all the relevant steps. Okay, so let's look what they mean. The rectangular hyperbola H has equation xy equals 36. The point P 4,9 lies on H. Show using calculus that the normal to hyperbola at P has this equation. Okay. This is something that you should be quite familiar with. How do we get the equation of the normal? What's the first thing to do here? When they give you xy equals 36 and you want to find the equation of the normal, first thing we do is we get the gradient of the equation, right? We get the dy by dx. That gives you the gradient of the tangent. So first thing I'll do here is I'll make y the subject. Y equals 36 over x. And what do I get here? So before I differentiate, I get y equals 36 times x to the power minus 1. Are you okay with it? Now we can go for dy by dx. Y is subjected. So dy by dx equals to, okay, so when we differentiate, we get here, we take the minus 1 in front, minus 36 x to the power minus 1, you subtract 1, minus 2. Are you with me? So basically your dy by dx is minus 36 over x square. Is that okay? Now what we do here is we need to replace the x value. So what's the x value here? At the point P, x is 4 and y is 9. Replace x is 4. Minus 36 divided by 4 is, x is 4. So 4 square. Can I have the dy by dx value? Minus 9 over 4. Okay, so this is the gradient of what? Dy by dx is the gradient of the tangent. Now we are supposed to find the equation of the normal. So what's the gradient of the normal? Tangent and normal are perpendicular. So gradient product is equal to minus 1, which means all you have to do here is switch the sign. Negative should become positive and take the reciprocal. You get 4 over 9. So plus 4 over 9 is the gradient of the normal. Are you? Do you agree with me? How do you get the equation of normal? The equation of normal will be y minus y1 equals to gradient x minus x1. Let's substitute y minus y coordinate here is we are going to apply 4,9, right? Y minus 9 gradient is 4 over 9 times x minus x1 is 4. So move the 9 to the other side. Shall we multiply? We are supposed to get it in all integer format. Take 9. 9y minus 9 is 81. Here we have only 4 now. So shall we open with 4? So we get here 4x minus 4 into 4 is 16. So I'll keep the 4x minus 16 here. Let's move here 4x plus 9y comes as minus 9y minus 16 and the plus 81. Minus 16 plus 81 is plus 65, which is the show that, which is for 4 marks. So make sure you show the relevant steps, especially the differentiation and the substitution of the x value and getting the gradient. So you get method marks for these steps. Make sure you show these essential steps. Okay, so show that. So make sure even the equation of the normal, we show the relevant, especially this step over here, it needs to be seen. Okay, and then you move and get the show that. Okay, do not take everything in one step because the answer is given. Okay, so in a show that it's better you write a few extra steps to make sure that you get the full mark. Okay. Then let's move to part B. The normal to hyperbola at P crosses the hyperbola again at the point Q. So what do they say here now? If you kind of draw like a visual idea of what's going on here. Now you know this is what the hyperbola is, right? A hyperbola is an equation that looks like this, isn't it? So you have this point P. At point P, what did we do? At point P 4,9, what did we do? We drew the equation of the, we got the equation of the normal, right? So normal is a line that goes perpendicular. That is, that cuts the line that is perpendicular to the tangent. So they say this normal equation which you found. Normal equation is what we found over here, right? This normal equation, they say it cuts the normal to the hyperbola at P, crosses the hyperbola again at the point Q. Do you see the point Q? According to my diagram, point Q is over here. Can you see? So I just give a rough idea to clearly understand what's going on here. Then they say determine an equation for the tangent to the hyperbola at Q. Okay. What do we need to do? We need to find the equation for the tangent to the hyperbola at Q. Giving you answer in the form y equal mx plus c, where m and c are rational constants. Basically, what you have to do is, first of all, you'll have to find what? The coordinates of the point Q. Are you with me? You have to first find the coordinates of the point Q and actually use those coordinates to find the equation of the tangent at the point Q. Are you following me? I need to get the equation of this yellow color line. The equation of the tangent at Q needs to be found. Okay, what's the first thing? What's the first thing we should do here? What's the first thing we should do here? We need to equate the equation of the normal with the equation of the hyperbola, because we need to find the coordinates of point Q. Are you with me? So what's the equation of the normal? We just found 4x minus 9y plus 65 equals 0. We have to solve it with what's the equation of our hyperbola? What's the equation of our hyperbola? xy equals 36. Okay, shall we substitute? So I'll get here y equals 36 over x. Is that okay? Shall we replace the y here with 36 over x? So I get here, when we substitute, 4x minus 9 times y is 36 over x plus 65 equals 0. And then what do we do here? What's the next step? Don't take the x to the other side, because you can see x is only there for one particular term. So there are 3 terms here. The best thing you do here is what? Take the entire equation, multiply the entire equation with x. Then what do you get here? 4x square minus 9 over 36 into x. The x will cancel out. That's the whole reason why we multiplied with x, to cancel out the denominator x. What's 9 times 36? 9 times 36 is 324, then plus 65 into x is 65x equals 0. Are you with me? So this equation, when I rearrange, it's 4x square plus 65x minus 324 equals 0. Can you all tell me the factors here? You can type ABC in the calculator. What are the 2 factors we get here? Does it factorize? Yeah, what are the answers we get? X, yeah. X minus 4 and 4x plus 81. Okay, so you get the answer. You type the ABC in the cell and gives you x equals 4 and x equals minus 81 over 4. So by that you reverse it and you get these 2 values over here, right? So then basically you get x minus 4 equals 0, which gives you x equals 4. I think x equals 4 is the value that we have for point P. Can you see? X equals 4 is the answer for point P. We don't need that. We need the other one. Who is the other one? 4x plus 81 equals 0, which gives you x is minus 81 over 4. So this is the coordinate we need. This is the x coordinate of point Q. Because you realize this is from which point? This is the point P. Because at point P, the x coordinate was 4. This should be point Q. Can I have the y coordinate here as well? How do we get the y value? Y equals to substitute 36 over x, right? 36 over x is minus 81 over 4. Can I have the answer here? Minus 16 over 9. So what's the point Q coordinate? Minus 81 over 4, comma, minus 16 over 9. Are you with me? Are you following me? Now what do we need? Are we just supposed to find the Q coordinate for 5 marks? No, they want us to find the equation of the tangent at point Q. Now to get the equation of the tangent, I need to know the gradient here. Do I need to get dy by dx again? Now we already got dy by dx of the curve in part A, right? What was dy by dx? Now you need to get the dy by dx, not the value that we are, you have to get the dy by dx in terms of x, because we have a new x coordinate to substitute. So your dy by dx was minus 36 over x square, right? So gradient of tangent. So the gradient of the tangent will be minus 36 over x square, which is minus 36 divided by what's our x square, minus 81 over 4 whole thing squared. You can type this entirely in the calculator, right? Type this entirely in the calculator. Minus 36 over bracket, and you type like this. Minus 81 over 4 bracket and square. Can you see the way I type in the cal? And you get minus 64 over 729. Minus 64 over 729. So that's the gradient of your tangent. So how do we get the equation of tangent now? So equation of tangent will be y minus y1 equal gradient x minus x1. You don't need to write this step actually. You can directly substitute and start from this step. Y minus, who is your y1? Minus 16 over 9. Gradient is minus 64 over 729. X minus x1 is minus 81 over 4. I think in this question they ask you to find make y the subject, right? Yeah, determine the equation of the tangent giving you answer in the form y equal mx plus c. Y needs to be subjected. So when you subject y, what do we get? Shall we open the bracket here? Y plus 16 over 9. Can you all expand the bracket? Minus 64 over 729 into x is minus 64 over 729x here. Minus into minus is plus. Plus into plus 81 over 4 multiplied by minus 64 over 729. Can you all tell me the answer? Be careful here. Minus 64 over 729 multiplied by plus 81 over 4. Are you following me? What is the answer we get? Minus 16 over 9. Can you all take this plus 16 over 9 to the other side? Because we are supposed to make x a subject. Minus 64 729x minus 16 over 9, and the minus 16 over 9 gives you minus 32 over 9. So this is the equation of the tangent at the point Q. Okay, so this is the answer for 5 marks. Is this clear? And all of you understand what I did here? This is okay? Okay, question number 8. Fx equal 2x to the power minus 2 over 3 plus half x minus 1 over 3x minus 5 minus 5 over 2. The table below shows values of fx for some values of x with values of fx given to 4 decimal places where appropriate. Complete the table giving the values of values to 4 decimal places. Okay. How do you give this to 4 decimal places? I think the most appropriate thing here is that you actually what? Type the entire equation in the calculator, right? That is the best thing to do here. Minus 2 over 3. Do you see what I'm doing here? I'm typing the entire equation in the calculator. Plus half x minus 1 over 3. I'm using the alpha button to type the x here. 3x minus 5. Are you following me? Minus 5 over 2. Okay, so for the first thing we do is we type the entire equation in the cal in this manner. And then what do? We give calc and give the x value. What's the first x value? The first x value. Let's type x equal 1 and check whether we get the 0.5. Because if we get 0.5, that means we got it correctly. Okay, so I get half 0.5. Do you see? Half is 0.5. Okay. The next x value is calc. The next x value is x equals 2. So they ask you to give the value to how many decimals? 4 decimals. What's the answer correct to 4 decimals? Minus 1.240. The fourth decimal is 0.7. The fifth is 7. So you have to add 1. Minus 1.2401. So this is the answer. Next one. When x equals 3, I don't need to check it. I don't need to check, but you can just use the value if you want. Okay, so we can see we can verify that it's correct, right? Minus 0.2885. The next x value we need to fill is when x is 4. So what is the answer? Correct to 4 dp minus 0.1508. Are you with me? 0.1508 correct to 4 dp. Do you agree with me? Is this clear? Okay, complete the table giving the values to 4 dp. That's done. Part B. The equation fx equals 0 has exactly one positive root alpha. Using the values in the completed table and explaining your reasoning, determine an interval of width 1 that contains alpha. First thing you need to realize here is what? Now, when you say that there is a root, how do you identify there is a root? On either side of the root, there is a sign change for what values? There is a sign change for the y values. So basically, you can see there are two now for two consecutive x values. Now, look, when you take x value 1 and 2, do you see the two y values are producing a sign change? Also there, in between 2 and 3, we don't have a sign change. So there is no root here. But in between 3 and 4, again, we see there's a sign change. So in between the x value 3 and 4, we have a sign change for the y. So now we have a debate here. Do we have the root in between 1 and 2 or whether it's between 3 and 4? Because they say here clearly, what? The equation fx equals 0 has exactly what? Only one positive root. There's only one positive root. We don't have two roots, but now according to what when I look here, it seems to me as if there are two roots because there are two places where I get sign change. So, but they say here there's only one positive root. Okay, how do we determine? They're asking determine interval of width 1. What do you mean by width 1? Interval of width 1 means what? Interval means the x value, the distance between your x values. I think you can see all these x values are of interval 1, right? 1 to 2 gap is 1, 2 to 3 gap is 1, 3 to 4 gap is 1. So all the x value intervals here are having a gap of 1, width is 1. But now you need to say whether your root is in between the interval 1 and 2 or whether your root is in the interval 3 and 4. Okay, now how do we say clearly? How do you determine the root is in which interval? So what we do here is, now the thing here is, if you look at this equation, you can see x is in the numerator for 2x to the power minus 2 over 3. Half x is also having x in the numerator. But do you see there's one fraction here where x is in the denominator? 1 over 3x minus 5. And you need to realize when x is there in the denominator, and if the denominator becomes a 0 in any kind of a graphical, when you draw the graph, when you have x in the denominator, and if there's any x value that makes the denominator 0, that x value will actually be what? That x value will actually be an asymptote to your graph. Now in 1 over x graph, when x equals 0 is an asymptote, right? Why? Because when x equals 0, you get 1 over 0, which is math error. So any x value, when x is in the denominator, that makes the denominator 0 will become an x asymptote. Do you see such a x value here? You can see we have 1 over 3x minus 5. Do you see it? So what is the x value that makes your denominator 0? Make the denominator 0. 3x minus 5 equals 0. And what do we get for x? X equals plus 5 over 3. Are you agreeing with me? What is 5 over 3? The figure, the decimal figure is 1.666. Basically, it's 1.7. Okay, so what does that, what is the idea here? It means in between the x value 1 and 2. I think you can see 1.666 is in between 1 and 2. So in between 1 and 2, what am I having? I'm having an asymptote, which means is the graph continuing from 1 to 2. Now the graph is broken. You have a discontinuous graph. The graph is discontinuous. So when you have a discontinuous graph, when you have an asymptote like this, part of your graph should go like going down like this. The other graph probably comes up like this. I think in this situation it's the other way, right? Like this and like this. Okay, because at x value 1, you have a positive y value. At x value 2, you have a negative y value. There is a sign change, but does it mean there's a root? No, why? Because in between we have an asymptote. X equal minus 5 over 3 is an asymptote. X equal 5 over 3. So x value 1 and x value 2 here, you can see the y values are giving a sign change. Your y values give a sign change. But there is no root here. Even though there is a sign change, because your graph is not continuous, it's not a root. You don't have a root in between 1 and 2. Do you understand what I'm saying here? So you don't need to draw any graph and explain, but you just need to give a reason here because you just need to give a reason for 2 marks. So how do we explain this? for 2-mark reasoning. How do we explain? You don't need to draw any graph. What you say here is what? You can say f is, your fx is what? Fx is discontinuous, right? Fx is discontinuous on the interval. It's discontinuous on the interval where to where? 1, 2, right? From 1 to 2. Fx is discontinuous in the interval 1 to 2. However, fx is what? I think you can see we don't have any other asymptotes, right? If there are no other asymptotes, it means the other part of the graph is continuous, which means the graph is connecting by the curve is continuing. You don't have any breaks in the graph. So in between 3 and 4, we don't see any evidence of any asymptotes here, right? Okay, because there's no other x value that makes your denominator 0. Okay, so fx is continuous on the interval. What's the interval that we are interested in here? The interval with the sign change between 3 and 4. We have no evidence of any asymptote other than the asymptote at 5 x equals 5 over 3, isn't it? So fx is continuous on the interval, and what else is there to support the root? We must definitely talk about what? There is a, now in your answer, you must also, now I only spoke about the continuous part. You must also mention about the sign change, because the sign change is the other thing that tells us there is a root. So fx is continuous on the interval 3, 4, and there is a sign change. Can you understand? And there is a sign change. So then what's the interval of width 1 that contains alpha? So the required interval is what? So the interval of width 1. Interval of width 1 containing alpha is? Containing alpha is what? 3, 4. Are you with me? Okay, so let's move to the next part. Just need to give a small explanation here. Okay. Okay, then the next one. Okay, because the next one they say hence use interval bisection twice. They wanted to use interval bisection twice to obtain an interval of width 0.25 that contains alpha. Shall we use interval bisection twice? Okay, so the first interval is 3, 4. So let's bisect the interval. So what's the, when you bisect once, what is the interval? You have to add the two x values and divide by 2. What is it? 3 plus 4 divided by 2 is 3.5, right? Can you all get me the f of 3.5? So we already have, I think I have already typed fx in the calculator. Can you see? So do not press the on button. I think if you just press the AC button, the final thing you type is still there in the calculator. So just make sure you retrieve it back. So I have the thing I typed in the calculator. All we have to do is what? Simply press calc and give the x value. What's the x value? 3.5. So what's the answer I get here for f of 3.5? Minus 0.064. Are you with me? Minus 0.064. So now the thing is, I need to now find the smaller interval that contains alpha, right? So to have alpha, there must be a sign change. So from their two previous value, f of 3 and f of 4, I think we had f of 3 and f of 4, right? Who was f of 3? We had the value f of 3 in our table. F of 3 is, can you see when x is 3, the y value is minus 0.2885. And what was the f of 4 value? That was a positive figure. What was the positive figure? 0.1508. Now what's the new interval? So what's the first, after the first bisection, what's the new interval? The root is in which interval? The root must always have the interval must contain a sign change, right? So you can see the new value after the bisection 3.5 gives a negative value for y. So 3.5, the other value should be one of the previous values from the previous interval, right? Either 3 or 4. Which one is the opposite sign? 4, right? Because you have a positive value. So your new interval will be between 3.5 and 4, because for 3.5 I have a negative value for y, for 4 I have a positive value. Are you with me? So this is interval bisection applied once, and this is the first interval. After I apply interval bisection once, we are supposed to apply interval bisection twice. Can we apply it again? Can you all bisect the second time? When you bisect the interval, add and divide by 2, 3.5 plus 4, add and divide by 2. How much is it? 3.5 plus 4, add and divide by 2, 3.75. So again, get f of 3.75. We already have the equation in the calculator. So again, just take the press calc and give 3.75. What's the answer? 0.04359. Okay, 0.0436, something like this. Which is a what figure? Which is a positive figure. So what's the root? The root is in the interval. What's the new interval? 3.75 is a positive figure. From the previous interval, I have to get the x value who gives the negative y. Now 3.5 gave me a negative y value. 4 gave me the positive y value, right? So here f of 3.5 is positive. So from the previous interval, I should take the x value who gives me the negative y. Who is it? 3.5. So what's the new interval then? The new interval should be from 3.5 to 3.75. Are you with me? Because at 3.5 we get a negative y value. At 3.75 we get a positive y value. Okay, and you can see here the interval width. Obviously, the difference between 3.5 3.75 is what? 0.25, because the first you need to understand when you bisect it once, yeah, interval length is becoming now the first original interval length was 1 with 1. When you bisect once, the interval length becomes half. Bisect it again, the interval length becomes 0.25. You can see it here. The difference between 3.75 and 3.5 is 0.25. So they say here to get the interval of width 0.25 that contains alpha. So this is the interval of width 0.25 that contains your alpha. Okay? Is this clear? Okay, given also that the equation fx equals 0 has a negative root. Okay? Has a negative root beta in the interval -1 minus 0.5. So you can see this is completely something else, right? This doesn't relate with part A, though the equation is the same. Now we are going to find the negative root. So they say very clearly the negative root beta is in the interval -1 minus 0.5. Use linear interpolation once on this interval, only once. And they tell you the method you should go here is by using linear interpolation once on this interval to find an approximation for beta. Okay, what's the first thing we should do? The first thing you should do here is in part D, get the y values. What are our y values? Get the f of -1 value, get the f of -0.5. These are the first things you should do. So already in the calculator, I think we still have the equation that we typed. So what we do here is again you give calc and give the x value -1, because it's the same fx equation that we are using. So what's the answer I get? I get -708 minus 0.875. Is that okay? I'll use -708. The other one, when x is calculate when x is -0.5, what's the answer I'm getting? So I get 0.5786. So in this case, try to use as many decimals as possible, because when you're using linear interpolation, now in interval bisection, the y values were not much accounted for, because we didn't use the y value. We were just bisecting the interval and getting the x value. But when you're using linear interpolation, the y values are also used to calculate the x value. So therefore, don't just check the positive negative sign and just write a few decimals. Write as many decimals as possible. Okay, so what's the answer here? 0. Can you all tell me the value? 57. Tell me the decimals. 0.5786. Yeah, continue. Because we need to have as many as possible. 0.5786, 48, 25, 78, right? Yeah, so you can at least take around 6 or 7 DPs, because you need to give you need to take a little bit extra. Better, the more you take, the better. Shall I make it 6 here? Because after 5 we have 7 and 8. So I can make it 6 here. Is that okay? Okay. So I have taken this to around 1, 2, 3, 4, 5, 6, 7, 8, around 9 figures. Okay. Then the next thing we do here is when we use when we use linear interpolation, we use similar triangles. Do you remember? Okay. So what are the two x values? The first x value is minus 1. The other value is minus 0.5, right? Okay, so what do we do here? When x equal minus 1, your y value is negative 708. Are you with me? The y value is minus 708. Are you with me? When x is minus 0.5, the y value is? This is minus 0.5. Y value is 0.5786, this value. Are you with me? Okay, so now what do we do now? We connect these 2 points and we make our triangle. So the place where it cuts the x-axis, this is the x1. This is the root. This is what we consider as the root. Are you with me? We are going to use similar triangles here. So how does similar triangle work here? Tell me. So we take the gap here, right? What is the gap here? Minus 0.5 minus x1. Minus 0.5, you subtract the x1, you get this gap. Divide by, take the gap, the x gap from the other triangle. X1 minus, who is this? Minus 1, right? So x1 minus 1. So those are the two x intervals here. Divide by equals to the other side, we write the y interval. So what's the y gap here? The vertical length. How much is the vertical length here? 0.5786, and just the whole thing, 5786.4826 over what's the y interval, the vertical length of the other triangle? Who is the vertical length of the other triangle? The vertical length, the y length. Now it's minus 708, right? Yes, this is really crucial here. Now many of you might make the mistake. This should be plus 708. Why? We are just getting the length here, right? You only need to get the length here. The y value here is 0.5786 is the y length here. Here it's plus 708. Do not use minus 708 here. Now for the x values, however, are we going to use the negative x value minus 0.5 as positive? No, because the reason is we are finding this x1 value. The x1 is supposed to be between minus 1 and minus 0.5. So for x1, you are expecting to see what answer? X1 is between minus 1 and minus 0.5, which means you realize x1 is a negative figure. You need to see your x1 answer must be negative. Okay, so don't go to do anything for the x figures. X figures, you do it exactly in this order. You just get the length difference, minus half minus x1. You get this length. Then x1 minus, you subtract with minus 1. But on the y side, the positive y value is okay, but the negative y value, you just need to get the length here. Do not give the negative sign. Okay, so now what? Now it's a matter of making x1 the subject. I think 7/8, the decimal figure was 0. How much was it? 0.875, right? Shall I use 0.875? Okay, so now you have to rearrange this equation and make what? Make x1 the subject, right? The x1 was the beta here, right? Approximation for beta. Yeah, x1 is the beta here. Shall we use instead of x1 beta? Let's use the term beta here. Okay, make beta the subject, shall we? Minus 0.5 multiplied by 0.875 minus beta multiplied by 0.875. Are you with me? On the other side, I get beta multiplied by 0.5786. This goes on. And then here minus is plus 1. So the other one is you multiply plus 1 with 0.5786. And the remaining figures are going on. Do you agree with me on this? Okay, so I need to take all the beta terms to one side and the other terms to the other side. So I'll take the negative beta term to this side, and I'll take this the term without beta over here. So what do we get here? Minus 0.5 into 0.875. I'll take the term here, minus 1 into 0.5786. It comes as minus, multiplying by 1 is the same thing, minus 0.57864826. I just wrote the full thing. On this side, what do we get? Are you capable of doing it at once? You can see this is also having a beta. The term that comes over here also has a beta. Shall I take beta out here immediately to save us a step? So I get here 0.57864826. Minus beta comes here as plus, and I get here 0.875. 0.875 is a fixed, a finite decimal here, right? Do you agree with me? So can't you make beta the subject quite easily now? Yeah, divide, type the whole thing in the cell and get the answer. Can you all type this whole thing in the calc? Get me the answer they want to how many decimals? Give your answer to 3 significant figures. Give it to 3 significant figures. Minus 0.5 into 0.875 minus 0.57864826. I think that answer was stored in the calculator. You could have used the answer in place here. Okay, this is okay. And I get the answer minus 0.699033. So this answer you should give it a 3SF. What's the 3SF answer? We'll write the first answer minus 0.6990. What was it? 331. Something like this, right? So beta to 3SF minus 0.699. This is the root correct to 3SF. Okay, is this clear? Question number 9, part A. Prove by induction that for n element of natural numbers, summation of r cube is 1/4 n square n plus 1 square. Okay, this is something that you learn in your textbook as well, right? So proof by induction, what's the first thing we do? First we check the proof when n equals 1, right? So when n equals 1, check the left hand side and the right hand side. Summation r equals 1 to n. We put from 1 to 1 r cube. How much is it from 1 to 1 means? Just replace r with 1. 1 cube is 1. Also check the answer when n equals 1. What's the answer for 1/4 n square n plus 1 square? What do we get? This is the left hand side. This is the right hand side. So what do we get when n equals 1? 1/4 into 1 square times 1 plus 1 square. What do we get here? 1/4 into 1 square is 1. 1 plus 1 is 2. 2 square is 4. What do we get here? 1/4 into 1 into 4 is 1. So left hand side when n equals 1, left hand side and right hand side are equal, right? Therefore, the summation result is true when n equals 1. Then what's the next step we do? We assume, right? When assume the summation formula is true, or assume the result is true. For what? For n equals k. So when n equals k, what happens? Summation of r cube, we take it from where to where? From r equals 1 to r equals k. Are you with me? We shall take the summation of r cube from 1 to k. What's the answer we get here? 1/4, the n is replaced by k. 1/4 k square, k plus 1 square. Are you with me? Then the next thing we do is what? The next thing we do is we take for n equals k plus 1 and we solve the equation manually. Summation of r cube from r equals 1 to k plus 1. So how do you open it manually? When you just replace r with 1, then r with 2, we get here 1 cube 2 cube. This goes on until what? Until you replace r with k plus 1. So k plus 1 cube. Can I know the value before k plus 1? It's k, right? So k cube, the last term is k plus 1 cube. This is the summation, right? Summation is you keep on adding. Okay, now what happens? Who is this guy? 1 cube plus 2 cube plus 3 cube until k cube. Who is it? This is the summation of r cube from where? From 1 to k. Do you agree that this is the summation from 1 to k? So that answer we already have, we have assumed that result. Assume the summation of r cube from 1 to k is given as 1 over 4 k square, k plus 1 square. And then so that we should add the k plus 1 cube. By the way, what's the answer that we are supposed to get? The result. We need to prove the result is what? When n equals k plus 1, we have to show that we get the result. What's the result? When n equals k plus 1, replace k plus 1 here for the result. 1 over 4, n is replaced by k plus 1 square. The other one is k plus 1 is k plus 2 square. So this is the result that we are supposed to get by opening the R cube, the formula manually. Shall we get it? I think the best thing we do here is take the common thing out. Are we going to open brackets? Are we going to expand brackets? Definitely no. Take the common thing out. I can take a what out? K plus 1 square out. Shall I take a k plus 1 square out? What's remaining? 1 over 4 k square, and the other one k plus 1. Because and shall we take the common denominator with 4? I'll take 4 as the common denominator, which means I have to multiply up and down with 4. Do you agree with me? Shall I take the 1 over 4 out? 1 over 4 out as common, 1 over 4 k plus 1 square. And I get here the 4, 1 over 4 goes out. This is k square. Here I get k plus 1 times 4. Do you agree with me? 1 over 4 k plus 1 square. Here I get k square plus 4k plus 4, which is what? 1 over 4 k plus 1 square. K square plus 4k plus 4 is the square of, actually you should see now. You're supposed to get k plus 2 square for your answer. So you need to realize k square plus 4k plus 4 is the complete square of k plus 2, which is the show that. This is the show that we are supposed to get. So you can say what? Hence, please give your conclusion. Hence, the result is true for what? Is true for n equal k plus 1. And then you can say the result is true for n equal 1. Okay, the result is true for all. We can, hence the result is true for n equal k plus 1. So write the statements. So the result is true for n equal 1 and assumed to be true. And assume true for n equal k. And what's the last one? And shown true for what? And shown true for n equal k plus 1. Then therefore what can we say? Hence the result is true for all n element of natural numbers. Yeah, they have told us n is the element of natural numbers here, right? N is the element of natural numbers by mathematical induction. Okay, are you okay with this conclusion? Make sure you give the conclusion. Okay, is this clear? Okay, moving on to part B, using the standard summation formula, show that summation r plus 1, r minus 1 is equal to 1 over 4 n, okay, n plus a, n plus b, n plus c. So standard summation formula. Okay, so to use the standard summation formula, what are the standard summation formula? Can you all remind me? Summation of r from 1 to n is what? Please remind me. Yeah, the summation of r from 1 to n is n over 2, n plus 1. Can I also know the summation of r square from 1 to n? 1 over 6, n plus 1, 2n plus 1. Check on this, please. Summation of r cube from 1 to n. I think that is actually, we should know it, and also it's proved here. 1 over 4 n square, n plus 1 square. So these are the equations, and also you should know the summation of 1 from 1 to n. Summation of 1 from 1 to n is n. So these are the 4 main equations that you are supposed to use. Are you with me? Shall we apply the summation formula for what they have given in part B? Summation r times r plus 1 times r minus 1. So let's apply the summation formula. Can you all expand the bracket here? Summation r times, shall we open r plus 1 into r minus 1? Who is r plus 1 into r minus 1? Like directly. It's a plus b, a minus b. Basically a square minus b square. So r square minus 1 square. So open the bracket. R into r square is r cube. R into minus 1 square is minus r, right? R cube minus r. Because 1 square is 1. 1 into r is r. So basically summation of r cube minus r. Now don't we know the summation of r cube from 1 to n? You could separate it out. Summation of r cube from 1 to n minus summation of r from 1 to n. Who is the summation of r cube from 1 to n? 1 over 4 n square, n plus 1 square. Am I correct? Summation of r from 1 to n is half n plus 1. Are you with me? So we need to get this, show that. How do we get this, show that? Shall we take the common thing out? Best thing is to take the common thing out. Who is common to both of them? N is common, and also n plus 1 is common. Shall I first take those two out, and we'll then fix the denominator? What's happening here? 1 over 4 n square, n plus 1 square. We have a n remaining and a n plus 1. Minus here there's a half remaining, n and n plus 1 goes out. Shall we fix it to a common denominator 4? Here we have 4. So to make it common denominator 4, I have to multiply the second fraction with what? With 2, right? So what do we get here? N into n plus 1. And here you get 1 over 4 n plus 1 minus 2 over 4. Are you all with me? Shall we take the 1 over 4 out? 1 over 4 n plus 1, and over in the bracket we are remaining with n plus 1 minus 2. Open the bracket and simplify 1 over 4 n plus 1. This becomes n square plus n minus 2. Can you all factorize this? What are the factors of n square plus n minus 2? Please tell me the answer. N square plus n minus 2. N minus 1, n plus 2. Thereby, so we got the answer for part B. 1 over 4 n plus a, n plus b, n plus c. Where a, b, c are constants to be determined. So a can be 1, b can be minus 1, c can be plus 2. Okay, is this clear? Then the next part, they say determine the. Okay, so moving on to part C, they say determine the value of n for which 3 times the summation of r plus 1, r minus 1 equals 17 times the summation of r square from n to 2n. So when you look at this part, you can see it's directly, this is, we can use the help of part B, right? So we already know the summation of r plus 1, r minus 1. So let's write this down, part C. Part C, so the summation of 3 times r plus 1, r minus 1 from r equals 1 to n. is equal to 17 times summation r square from n to 2n. So we already know this answer. This is what we got in part B. So 3 times, there's extra 3 here, 3 times. The answer we got in part B was, what was it? 1 over 4, n plus 1, n minus 1, n plus 2. Am I correct? This is what we got for part B, right? 1 over 4, n plus 1, n minus 1, n plus 2. Okay. So this is equal to 17 times summation of r square from r equal n to 2n. Okay. So now all I have to do is to get this particular value here, summation of r square from n to 2n, and we have to solve this equation and determine the value of n. Okay, so you can see summation of r square from n to 2n. It doesn't start with 1. Now you can see I have written here the summation of r square from 1 to n. Summation of r square from 1 to n is 1 over 6n, n plus 1 to n plus 1. But here we have the summation of r square from n to 2n. So it's not starting from 1. These equations are only valid if you start the summation with r equal 1. So then if you have n to 2n, what's the formula we use? So we have the equation that you learn in F1. If you have f of r from r equals a to n, this is equal to summation of f of r from r equal 1 to n minus summation of f of r from r equal 1 to a minus 1. Are you aware of this rule? So here we do not start from 1. We start with some other figures. In this case, we take the summation from the first term to the n term and then subtract from the first term to a minus 1. So when you subtract from 1 to a minus 1, we are going to remain, the terms from a to n will remain. So this is the formula that I'm going to use. Okay, so I will first take care of this part now. Shall we look into this part? So what is it? I have here 17 times summation of r square from r equal n to 2n. Let's get this answer. So this is 17 times summation of r square from, so let's get the answer. R square summation from 1 to 2n. Can you see? I'll keep the 17 out. Okay, so from n to 2n means we take the summation from 1 to 2n, like in following the rule. So minus the summation of r square from 1 to, what is it? So here when you have a, we use a minus 1. So here I'm starting with n, thereby this should be n minus 1. Are you with me? Okay, so then let's simplify. Summation r square equation, if I write it down, summation r square equation was, summation r square equation from 1 to n, it was 1 over 6n, n plus 1 to n plus 1. Am I correct? So these are the rules that I'm going to use here. Right, summation of r square from 1 to n is 1 over 6n, n plus 1 to n plus 1. Okay, so let's use this and get our answer. So this is equal to 17 times summation of r square from 1 to 2n. If you have from 1 to 2n, it means the n is replaced by 2n. So all the n's in this r square summation r square equation must be replaced by 2n. Okay, so 1 over 6 times 2n into 2n plus 1 into 2 times 2n is 4n plus 1. Are you with me? Minus summation of r square from 1 to n minus 1. So in this case, we replace all our n's with n minus 1 because we start from 1 to n minus 1. Replace every single n with n minus 1. 1 over 6, n minus 1, n minus 1 plus 1 is, n minus 1 plus 1 is n, right? And then, wait, let me write it properly over here. 17 times 1 over 6 into 2n plus 1, 4n plus 1 minus, okay, I wrote the first part again. Let's input n as n minus 1. 1 over 6, n minus 1, n minus 1 plus 1 is n times, this becomes 2 into n minus 1, right? So 2 into n minus 1 is, shall I directly open? So 2 into n minus 1 is 2n minus 2 plus 1. Are you with me? I replace the n here with n minus 1. So that will be multiplied by 2. So 2n minus 2, that's what I get here. Okay. Okay, so let's simplify this bracket now. Okay, so then let's simplify. This gives me 17 times. Shall we take the, okay, wait, before taking the common thing out, I think 1 over 6, 2n. I'm not going to cut the 1 over 6 and 2n at this point. N minus 1 into n into 2n minus 2 plus 1 is 2n minus 1, right? Okay, so I'll take the common thing out. 1 over 6 is common to both of them and n is common to both of them. So I will take them out. So while 17 is out here, I'm taking a 1 over 6 and n out. So I'm remaining with 2 times 2n plus 1, 4n plus 1 minus 1 over 6 n goes out. I'm remaining with n minus 1, 2n minus 1. Let's open the bracket, simplify. So this is 17 over 6n times. This is 2 into, so I'll keep the 2 out. 2n into 4n is 8n square. Plus 2n plus 4n is 6n. Plus 1 into 1 is 1. Minus, again, the minus mark is there. So keep the minus. And open a bracket when you expand it, because the expanded terms will multiply with the negative. Okay. So n into 2n is 2n square. Minus n minus 2n is minus 3n plus 1. So then simplify 17 over 6n. And I get here 16n square plus 12n. I'm opening the bracket with 2 plus 2. And here we expand the bracket with the negative sign. So I get minus 2n square. Minus into minus is plus 3n. Minus into plus is minus 1. Are you with me? So when I simplify here, I get 17 over 6n. 16n square minus 2n square. That gives me 14n square. 12n plus 3n is 15n. 2 minus 1 is plus 1. Okay, so what is the answer that I got here? This is the summation of r square from n to 2n. I got the summation of 17 times r square from n to 2n. Okay, so shall we substitute the value into the equation? So let's substitute. I'm supposed to find the answer for this, right? Okay, so let's write it down. Okay, so this is the question. So let's simplify and let's input the values now. We have found all the answers 3 times. This answer, the answer we found in part B, 1 over 4n, n plus 1, n minus 1, n plus 2, which is what we got in part, in the previous part. In part B, this is equal to 17 over 6, n, 14n square plus 15n plus 1. Okay, so are you with me? So let's simplify. This is 3 over 4n, n plus 1, n minus 1, n plus 2, 17 over 6n, 14n square plus 15n plus 1. We can factorize this as 14n plus 1 into n plus 1. You can type ABC in the cal and get the factor. So you will get x equal minus 1 over 14 and x equal minus 1, which you can immediately factorize. Okay. So now n has to be, now we are finding the value for n here. N has to be a positive integer, isn't it? You're trying to find a positive integer. So you can see n, you can remove it. So shall I remove the n? I will remove n here. And also n minus 1 also, sorry, n plus 1 also I can remove, because n equal minus 1 is also not a solution, right? N equal minus 1 is also not a solution. I can remove that. So I get here 3 over 4 into n minus 1 times n plus 2 equals 17 over 6 times 14n plus 1. Okay, so I remove the common terms in here. Once again, why I remove the n and n plus 1, because n equals 0 and n equal minus 1 is not a solution. Okay, so these are not, because n has to be a positive integer. Okay, let's simplify. So I get here 3 over 4 into 6. I got the 6 here because I want to simplify the 6. Okay, so you can simplify this in any way you see fit. This is 17 times 14n plus 1. So I'll simplify here 2 times 3, 2 times 2 is 4. So I get here 3 times 3, 9 over 2. Let's open the bracket here, n square plus 2n minus 2, right? Equals here 17 times 14n plus 1. Let me bring this 2 to the other side. So I get here 9 times n square plus n minus 2. 17 times 2 is 34 times 14n plus 1. Okay, are you with me? So let me open the bracket here. This is 9n square plus 9n minus 18. So I get here 34 times 14, which is 476n plus 34. Okay, so I end up getting here 9n square, 9n minus 476, taking everything to one side. 9n minus 476n is minus 467n. Minus 18 minus 34 gives me minus 52 equals 0. Do you agree with me? I took all the terms to one side. Okay. Okay, so let's factorize now. So degree 2, a is 9x square minus 467 minus 52. So I get the first answer, x is 52 or n is 52. The other one, so n minus 52. And the other answer, n equals minus 1 over 9. So 9n plus 1. So we get here n equals 52 or n equals minus 1 over 9. So you know this is not possible. Yeah, n is supposed to be a positive integer. So n value should be 52. Okay, is this clear? Yeah, n value, the answer in part C. So you have determined the value of n. So you realize n has to be a positive integer. Okay, so n value has to be 52. Okay, so is this clear? So this is the end of the January 2022 F1 paper.